Hello friends, welcome to the Tech Granth. Today we are going to learn about a system design problem for movie ticket booking. So let's get started with it. So the requirement for today's interview problem is we need to design a movie ticket booking system, and in India the most common one is BookMyShow. So the requirement says that a person should be able to book the ticket based on the city he is residing, the movie that is playing currently, the theaters, and the theaters should be aligned like the theaters which are near to him. And once he selects the theater, then he should be able to select a particular show for that movie. And then once he has decided about the movie, then he should be able to select the seat and book it. And we need to handle the concurrency for this system because for a lot of the shows which are like newly released show or the hot shows that are there, so multiple user will be trying to book a seat, so one seat should be allocated only to one user. So the concurrency is very important factor in this system design. The second important factor is the security, because we will be dealing with payments and money, so the system should be highly secure. And database, of course. So the database should be able to handle both the transactional data and unstructured data, because there will be cases where you have relation between various entities, like you have a relation between a user, the theater, the movie, the seats. All these can be linked to each other in one to many kind of relationship. And also you will have some unstructured data like people posting comments, the reviews, and a short note about the movie, all those kind of things. So you need to have database which can handle both of these kind of scenarios. So we'll learn about that also, that what all database that you can use for this system. The various APIs that you will be dealing with, these are not the exhaustive list. There can be many more, but these are the pretty basic ones. So first, when you log in or you visit the page or the app of the application, you should be able to select your city, and from a list of cities that where your application has been rolled out. Then based on the city, you should be able to browse the theaters or the movie. The other way around, the 2 and 3 can go other way around also. Like based on movie, you can select theater, or based on theater, you can select movie. Those two APIs can be provided. And once you have selected the movie, then based on the movie, you need to get the auditorium. So a theater can have multiple auditoriums. So you need to get the auditorium in which that movie is playing. Once you have the auditorium, then you need to get the show. So in one auditorium, multiple show will be running throughout the day. So you need to get the show for that is running in an auditorium. And once you have the show, you need to show the user the list of available seat for that particular show. And you also need some graphics like the distance of the seat from the theater from the screen, and also the various categories like the front row seat or the back row seat or the VIP seat, all those things that needs to be shown as part of the available seats. And once the user has selected the seat which he wants to book, so he should be able to book the ticket. So once the booking is done, then the ticket has to be sent to the user using mail or SMS. And yeah, of course, you should be able to post your comments and reviews, everything. So these are the basic APIs that should be there as part of your system. And let's see how you will design a system which can incorporate all these APIs. At a very high level, the system design will look something like this. But before going deep into the system design, I will take the example of Fandango, and I will go through that website, and I will show you how we can select seat and how we can select city, then the theater, then movie, and finally the seat for booking purpose. And then we'll come back to this slide and we'll relate that to this system design. So let's go and check out Fandango. So I'm going to take the example of Fandango here, and the first thing you see that it asks me to enter the city code. So if I see here, I can select the zip code or the city for which I want to book the ticket. Next thing is that I can select the theater that is available. So I can select one of the theater here, and if I go to the theater, then it has the various movie listing that is available for that particular theater. So here if you see, I can just go and pick up one of the timings. So it means that I'm going to pick up this movie for that particular timing, and I can select how many seats I want to choose, and then I can go and select for the seats that are available. Basically it shows that this part is the screen, so all these blue are the available seats, the crossed ones are not available, and if I choose these, so it denotes that this is my seat which I have selected. So that is the example. This is the kind of system that we are going to design. Let us relate this system design which I have drawn here with the example that I saw you for Fandangos. So I was the user which made a request, and the first request that I made was to select the city. So my request went to one of the application server, and from application server the request was routed to a distributed cache. So the distributed cache can be something like a Redis cache. Do check out the video on how you can design a system for distributed cache. The link is there in the description, that I've already prepared a video on that. So for the most part, like the steps that I took was I selected the city, then I selected the theater, then I selected the movie. So all these requests can be served from the cache, because most of the people will be using that, and if it was not available, it will be pulled from the database. But in most of the scenarios, all these data can be pulled from the cache itself. So when I made a request for city, when I made request for the theater, and then I made request for the movie. So all these three requests was routed to the distributed cache, and the response was given from there. Once I have the final listing of the timing that I showed you, so when I clicked on the timing to select the seat, so that time a request was made from the application server to the theaters API, which gave me back the list of the available seat. So the page that you saw where there was a screen and the seating arrangement, so that distribution came from the theaters database or theaters API. And then I selected one of the seat. So once I selected one of the seat and pressed next, so that time a request was again made from this application server to theaters API to block that particular seat. So that seat was blocked for me, and then I will be directed for payment. So how it works here is, so this application server made a request to theater API to block that one seat for me, and then I will be redirected to this payments. So this payment can be a payment gateway where I will have different option, either pay by the credit card or debit card on internet banking or all those kind of stuff. So once I'm redirected to the payments gateway, I can make my payment, and if the payment is successful, in that particular case, that response will be received again by the application, and then the application server will send a request to theaters API saying that the ticket has been booked finally for the user. And once it is booked, then this application server will make another request. It will put a request in the queue here, and this queue is for sending the tickets. So that ticket will be sent to the user via a mail or an SMS or a WhatsApp kind of message. So as you know that most of the time these days we work on the QR code. So a QR code is generated for a ticket, and that QR code is sent to the user, and that user can show the QR code when he is entering the movie theater. So this is the whole design for one user when he makes all these requests. Now the second thing and the most tricky part of this system design comes when multiple users are making the request to book the same seat. So the seat which I selected, if some other user has also selected the same seat, how the system will behave. So how the system should behave in that particular case is that system should put a lock on that particular seat, and it should not allow two users to book the same seat. So how we will achieve that concurrency? If it was just one application server, then maybe we could have handled it as part of the application logic itself. Like in Java, you can handle concurrency using synchronization. But since there are multiple application server here, so you cannot basically you cannot use synchronization at application level. So what we will do is that synchronization or that lock we will be taking at the database level. So what this application server will do is, as soon as it gets the first request, it will send the request to the theaters API, and there at the database level a lock will be taken on the row. Now that lock will be can be taken in multiple ways. So either it depends on the isolation level of the database. So if it is like read committed, so in that particular case, as soon as one update happens, it will lock one row, and that row will correspond to the seat ID of the seat which I have selected. Now once that row is locked, then no other user will be able to access that particular row. So if no other user is able to select that row, what will happen is then it will return some error back to the application server. Now when it returns back that some error here saying that the row is locked or is not available, or whatever is the response from the theaters API, that needs to be translated and it has to be sent to user saying that the seat is not available for you. And then till the payment is done, or for a time limit of like 5 minutes to 10 minutes, that seat should be kept logged. If even after 5 minute or 10-minute time, whatever is set, if that payment is not finished within that time frame, then the application server will send a request to cancel the payment, and it will send a request to the theater API to release that particular seat. So that is how the concurrency will be maintained. Now, once we know about the concurrency, the next thing is why we are using two database here. So here two database are of two types. One is of type RDBMS, other is a NoSQL. Now RDBMS will be used to store all the structured data that we have, like where we find a entity relationship. For example, it can store a user data, it can store a movie data, it can store the relation between the movie and the theater, it can store the relation between the bookings. So it can store, basically you will need a booking history for each user, so the booking and payment history can be maintained in this database as well. And why we need a NoSQL here? So a NoSQL is used to store all the unstructured data. So other than the booking and the user information, there will be some other information like a user posting a comment or a review for a particular movie. A user can or the movie or the theater that is releasing the movie can give a little synopsis of the movie, or you can put a trailer. All those things, all those kind of data can be stored in a here in a NoSQL database, which are not structured. The other kind of unstructured data that is available in our system is from the user session. So suppose this user visited our application and he browsed through he or she browsed through the application and he selected some theater. Then the data which is like a user has visited the theater multiple times, or a data something like a particular genre of movie this user is watching every now and then, is booking for that particular kind of movie. So all these unstructured data can be stored in NoSQL, and it can be passed to a suggestion processing engine which can be based on Spark ML or some ML technology, which can be used for, which can then process all these unstructured data and give suggestion to the user. For example, if this user is watching, or in the history he has booked for an action movie for like 10 times or so, we can give back a suggestion saying that these are the action movie which are getting released in the coming weeks. So these kind of suggestion can be given back to the user. That is why a suggestion processing system is necessary. So this was the basic system design for a ticket booking or a movie ticket booking kind of application. I will show you the simple classes or the base class that is necessary, but that is not an exhaustive list. So the base classes that are required are the user class, the movie, theater, and the booking. So you will have information of the user. Each of these class will have an entity behind it which will be stored in our database. So this is how I designed a system for a movie ticket booking. Do let me know in the comment section how you designed it, or is there anything which I'm missing in this particular system design. So that's it for this video. See you in the next one. Thanks for watching.